Hello students, and welcome to Crop Science 6049. In today's lesson, we are going to look at water properties or properties of water. By the end of this lesson, you must be able to describe water properties in relation to its functions. So first of all, let's take a look at the structure of water before we actually get into the properties of water. Water is made up of two hydrogen atoms. As you can see here, water is made up of two hydrogen atoms joined together with an oxygen atom by sharing electrons in covalent bonds. Although the water molecule is neutral, the oxygen atom retains a slight negative charge, this one, and also the hydrogen atoms, they also retain slight positive charges, and this is what makes a water molecule polar. So a water molecule is a polar molecule. Now let's take a look at the properties of water. So water has the following properties. First of all, we want to look at the high specific heat capacity of water. Water has a high specific heat capacity. Specific heat capacity is the amount of energy needed to change the temperature of 1 kg of water by 1 degree Celsius. And water has a very high specific heat capacity. It needs to absorb about 4,184 joules of heat for the temperature of 1 gram of water to be increased by 1 degree Celsius. So what does this mean? It means that the temperature of liquid water rises and falls more slowly than of most liquids. And in simpler terms, water resists temperature changes. So water absorbs heat without immediate rise in temperature. And it also retains temperature for a much longer period than other substances. And this property is important in water's role as a thermal buffer and helps plants to avoid overheating. Next, let's look at water's high heat of vaporization. High heat of vaporization is the amount of heat that is required to convert a unit mass of liquid water to vapor without changing temperature. So for water, at its normal boiling point of 100 degrees Celsius, the heat of vaporization is 2,260 joules per gram. So it means converting 1 gram of water at 100 degrees Celsius to 1 gram of steam at 100 degrees Celsius, 2,260 joules of heat must be absorbed by the water. And also conversely, when 1 gram of steam condenses to give 1 gram of water, 2,260 joules of heat must be lost to the surroundings. So it takes a lot of heat to vaporize a given amount of water because hydrogen bonds must be broken in order for molecules to become gas. So as water molecules evaporate, the surface they evaporate from gets cooler through a process that is known as evaporative cooling. And in plants, when water evaporates during transpiration, it takes heat from the surrounding water, and as a result, the remaining water becomes cooler, cooling down the plant. Next, we want to look at the anomalous expansion of water. This one is a very unique and abnormal property of water. So anomalous means deviating from the normal. Anomalous expansion is an abnormal property of water, as I have said, whereby instead of contracting when temperature goes from 4 degrees Celsius to 0 degrees Celsius, water actually expands. and becomes less dense. So the density becomes less and less as it freezes because molecules of water form open crystal structures when in solid form. If water is cooled, its density gradually increases up to 4 degrees Celsius. When cooled further to make ice, it expands with decrease in density. Next, we want to look at water as a universal solvent. Water is a universal solvent because it dissolves more substances than any other liquid. It means that wherever water goes, either through the soil or the plant system, it takes along valuable chemicals, nutrients, and minerals. So water's chemical composition and physical attributes makes it such an excellent solvent. Water molecules have a polar arrangement. From what we have discussed when we're looking at the structure of water, water is a polar arrangement of oxygen and hydrogen atoms. One side is a positive electrical charge and the other is negative charges. So this allows water molecules to become attracted to any other different type of material and makes it possible for water to transport dissolved substances from one part of the plant to the other. Next, we want to look at the high heat of fusion of water. Water is a high heat of fusion, and high heat of fusion is the amount of heat required to convert a unit mass of water, for example 1 kg, into liquid water without changing temperature. So for water at its normal freezing point of 0 degrees Celsius, the specific heat of fusion is 334 joules per gram, meaning that to convert 1 gram of ice at 0 degrees Celsius to 1 gram of water at 0 degrees Celsius, 334 joules of heat must be absorbed by the water. And also conversely, when 1 gram of water at 0 degrees Celsius freezes, it loses the same amount of heat to give 1 gram of ice. So this property enables plants to resist freezing if temperature falls below 0 degrees Celsius, since all plants contain water. This enables water to continuously move within a plant even if the temperature is low. So if water had low heat of fusion, it would freeze with a slight drop in temperature, causing plants to be damaged by frost and causing tissue necrosis. Last, we want to look at adhesion and cohesion. First of all, let's take a look at cohesion. Cohesion is the attraction of water molecules to other water molecules. Water molecules have strong cohesive forces due to their ability to form hydrogen bonds with one another. Cohesive forces are responsible for surface tension of water. That is the tendency of the surface of water to resist rupture when placed under tension or stress. Water molecules at the surface will form hydrogen bonds with their neighbors, just like water molecules deeper within the liquid. Since water molecules are exposed on one side, that is at the top, they will have fewer neighboring water molecules to bond with and will form stronger bonds with neighboring molecules they do have. Surface tension of water allows it to support small objects, for example like a needle, when placed carefully on the surface. In plants, this allows water to form a continuous column in the xylem vessels that can withstand tension created in the xylem vessels. It allows plants to draw water from the soil and enables it to move up the plant through the xylem in a continuous column that does not break. Let's take a look at adhesion. Adhesion is the attraction of molecules of one kind to molecules of different kind. So adhesion is the attraction of water molecules to other surfaces. So water molecules can adhere to molecules of different kinds. For example, adhesion enables water to climb upwards through a thin glass tube placed in a beaker of water. And it also enables water to move up the xylem because water molecules will be attracted to the walls of the xylem. This upward motion against gravity is known as capillary action. Thank you for watching. Don't forget to subscribe to this channel. If you have any questions, additions and subtractions, please write them in the comment section. If you have benefited from this video, please click the like button.